Hello and welcome back to the channel. In today's video, let's learn about Apache Airflow, which is a powerful tool that helps you schedule and manage your tasks just like setting a reminder or an alarm, but for your computer program. If you want to move some data and then clean and save it somewhere, Airflow helps you do all this automatically and in the right order. It just works like a flowchart where each step is a particular task and you can connect these tasks to run one after the other. It is mainly used by data engineers to handle large workflows in big companies. So with Airflow, you write the tasks in Python and it takes care of running them on time, showing progress and retrying if something fails within the tasks. So if you are interested in data automation or tech jobs, then learning Airflow is a great start. Let's begin with definition of Apache Airflow. Apache Airflow is nothing but a platform designed to programmatically author, schedule and monitor workflows. And it is also called as orchestration tool that helps managing, automating complex tasks, especially in the context of data pipelines. So, as part of orchestration, we have already talked about authoring. Authoring workflows is nothing but creation and definition of the sequence of tasks to be executed as part of a workflow. Basically, we will be creating a Python script for this. Scheduling workflows. It is nothing but all those Python scripts as tasks will be set on the time and the frequency also will be set for the workflow execution. So after authoring the Python script, which is a sequence of tasks, we have to schedule on a particular time and we have to set the frequency. Like if I want to execute the workflow every day in the morning 3 a.m., then the timing is 3 a.m. and frequency is daily. If I wanted to execute weekly, timing is 3 a.m. and frequency becomes weekly. And it depends on the frequency. It can be yearly also, we can set. That is scheduling workflows. The third one is monitor of workflows. So once we monitor, which is nothing but tracking the progress. Once we have scheduled the workflows, we need to monitor to check the progress, whether it is completed or it is in progress or it has failed. Then we have to find the status by checking this particular workflow, which is nothing but monitoring workflows. It is very important in your real-time data pipelines. So now let us look into key concepts and functionality of Apache Airflow. Airflow is nothing but workflows as code, as we already discussed. We will write Python scripts. So then there are major advantages like version controlling. Basically, developers will be using GitHub like tools for collaboration and version controlling. Testability. Testability is for because we will be creating code-based workflows. It has to be tested for correctness and reliability of the scripts. And then dynamic generation is nothing but these workflows can be dynamically generated based on external data or configuration, which is part of our Apache Airflow configuration section that we will be seeing in further videos in detail. So what are major advantages? Version controlling and then dynamic generation with external data and configurations and testability because code based workflows you need to remember. And the main important concept we have to understand is DAG, directed acyclic graph, which is nothing but sequence of tasks. We will be writing the tasks as in Python code and we will also set the sequence within the DAG. So now workflows in Apache Airflow are represented as DAGs. DAG is a collection of tasks organized in a way that reflects the dependencies. And every DAG has a particular set of tasks. So task is nothing but individual unit of work within a workflow. For example, if you take a Python script or execution of some SQL query within the Python script or transferring data in the Python script can be a independent task, which is a part of a DAG. And we have dependencies. So when we define tasks, we have to define the order in which the task should be executed. And a task can only run after its dependencies have successfully completed. And third is acyclic. The graph must be acyclic, meaning there should be no circular dependencies. Task A depends on task B, which depends on task A cannot happen. Let's understand the DAG in Apache Airflow. So the task is nothing but a Python script executing SQL query or data transfer within the Python code. And then dependencies, we have three tasks, task A, task B, task C. There will be interdependency in these particular tasks and acyclic. They cannot be dependent like acyclic way. So they are always acyclic. Task A can be dependent on task B. Task B can be dependent on task C. But in this case, task B cannot depend on task A backwards again, or task C cannot be dependent on task C, task A. So it will be in a sequence. Like I said, task A can be dependent on B and then B can be dependent on C and that's acyclic. That's about DAG. Now let's see the major concepts of Apache Airflow, which is scheduling. As we have already seen, Airflow provides scheduling capabilities and automatically trigger workflows at a specific time and frequencies. We have three types of scheduling. One is cron expression. You can use cron expressions to define complex schedules like running a workflow every day at a particular time. And we have time-based scheduling, which is nothing but workflows. Workflows can be scheduled at specific time and interval. And third type, event-based scheduling. Workflows can be triggered by external events such as arrival of a new file into the data lakes. So these are three types of scheduling. So before scheduling, we have to identify scheduling needs and choose scheduling method, as we have three: implement a cron expression or set time-based schedule of workflow, or configure event-based triggers. This is all about schedule. The next major concept is monitoring in Apache Airflow. Airflow provides UI for monitoring the statuses of workflows and tasks, where you can also manually execute the workflows to see how it performs. The real-time monitoring process is shown in this diagram. First, you access the Apache web UI and then identify the issues, analyze the performance as part of real-time monitoring. You can also view the history of the execution workflow, and then you can configure alerts whenever there is a failure. That is about monitoring. The next concept is extensibility in Apache Airflow. Airflow is highly extensible, that allows you to integrate with other systems and technologies that you will be looking into in the further videos. So for the enhancement, Airflow has particular capabilities, like it has operators, it has hooks, and then custom operators and hooks. So what is operator? Operator is nothing but a pre-built component that perform common tasks. So when you are writing a DAG, you can have operator, which is a pre-built component that perform certain common tasks, like running a bash command. If you set a task to execute Python script and you wanted to execute another task to run bash command, then you will have to specify operator to run the bash command as part of that task within the DAG. And then you can also execute a SQL query using this operator. You have to use that particular operator. We will be seeing the detailed operators in the next video. And you can even perform transferring data to S3 using a operator in Apache Airflow. And we have hooks, which is nothing but interface for connecting to external systems like database, cloud storage, and APIs. So we have seen before that Apache Airflow can connect to external systems like databases and cloud and APIs. So this is possible using hooks in Apache Airflow DAGs. And you can write operators, customized operators, and customized hooks also. So this will be used for your specific needs in your DAG design. And what are the main use cases that Apache Airflow will be utilized? We have Apache Airflow. Major use cases are ETL pipelines, data warehousing, machine learning, business intelligence, data science, general automation. So these are use cases in Apache Airflow. So ETL pipelines. What is ETL pipeline? Extract, transform, unload as part of data pipelines, automating the process of executing the data from various sources. Like normally in our data engineering projects, we will be having different sources. We will be automating extraction of data from those sources and then transforming into a usable format and loading it into data warehouse or any other particular data destination. It is called ETL. Now the second use case is data warehousing, managing the data pipeline and populating, maintaining the data warehouses is nothing but data warehouse implementation. And third is machine learning, in which we orchestrate the training and deployment of machine learning models. And fourth is business intelligence. So automating the generation of reports and dashboards is also possible using Airflow. And in data science, managing the data processing and analysis workflows is also possible with Apache Airflow. Last is general automation. So if you have any task, you can automate using Apache Airflow. It's all about major use cases using Apache Airflow. So now let's look into some benefits of Apache Airflow. So as we have been discussing, automation is one of the major benefits. So it automates complex workflows, reducing manual efforts and improving efficiency also. And reliability, as it provides robust error handling and retrial mechanism. It ensures also workflows complete successfully. And scalability, it can scale to handle large and complex workflows. And visibility, it provides a UI for monitoring and knowing the status of workflows. Collaboration, it allows teams to collaborate on workflows using version control and code reviews. Extensibility, it can extend to integrate with other systems and technologies. Open source, it is free. Open source meaning it can be used and modified in your own data pipeline orchestration. So these are major benefits: collaboration, automation, visibility, scalability, reliability, extensibility, and open source technology. Let's see one of the examples that we will be using Apache Airflow DAGs to implement. So you need to build a data pipeline that has three steps. One is extraction, second is transformation, And then third is loading the data as in this diagram. So where you have to extract data from a database and transform data by cleaning and aggregating it and load the data into a data warehouse. This is the scenario. So how do you solve? Using Airflow, you can define a DAG with three tasks. First task is extraction of task, extraction of data, that is nothing but extraction task that uses a database operator. In our Airflow, we have operators. For extraction data, we have database operator to extract the data. And transformation task, we can create a Python script to perform all the transformations on the data. And load task that uses a data warehouse operator to load the data into data warehouse. So that is about task and sequence. First is extraction task, and then transformation task, and then load task as shown in this diagram. So then after creation, which is nothing but authoring the workflow in the previous steps, we have to schedule the DAG to run to do workflow execution. So let us execute at 3 a.m. So Airflow would automatically execute these tasks in the order we have specified, handling all the errors and retries as mentioned in the parameters of DAG. We will be looking into those parameters in the next videos, and then monitor the progress of DAG in the Airflow and receive alerts if any task fails. So that has to be configured when authoring and scheduling the workflow. So before scheduling, we have to author the workflow. So first step, scheduling the DAG and execution of each and every task and handle the errors, monitor the progress of workflow, and then receive any alerts in failure cases. That's about scheduling of DAG in our example scenario. Scheduling a DAG, we can do it from UI and execution of tasks, that is automated using our workflow, scheduling, handling errors. It is automatically supported in Apache Airflow and monitoring progress. If you want, you can go and check in the UI for the progress, and you can also configure alerts if there is any failure occurs. So finally, let us summarize about Apache Airflow automation hierarchy, which provides business value and monitoring capability and scheduling, and its core concepts like code-based approach and DAG representation makes it powerful tool among other orchestration techniques. So Apache Airflow is a powerful and versatile workflow orchestration tool that can be used to automate and manage a wide range of data pipelines. It is code-based approach, meaning DAG representation, scheduling capabilities, and monitoring features make it valuable tool for data engineering projects or data scientists and anyone that needs to automate complex workflows. Then, by understanding its core concepts and functionality, we can leverage Airflow to build robust and reliable data pipelines that drive business value. So that's about today's video. Hope you understand what is Apache Airflow and you had better learning. Thank you for watching.